Let me introduce Jim and Jay. Jay is with Numurus, and Jim is with 5G Open Innovation Labs. Jim is also part of the Washington IoT Council. I'll let him describe the goal of that and what they're trying to do with that. But Jim, you want to introduce yourself,
Sure.
how you ended up here and what you're doing, and then Jason or Jay.
Yeah, absolutely. First, Hans, thanks very much for organizing the meetup and inviting us to present today. We appreciate that. Hey, everyone. My name is Jim Brisimitzis. I'm the founder of the 5G Open Innovation Lab here in Seattle. I brought on Jay Seawall from Numurus. Jay was part of our first batch that kicked off in early May. So, Jay, thank you for coming on board. Do you want to take time to introduce yourself?
Yeah, and I have to say thank you back, because I've sat on a few of these meetings and always thought, man, I really love to present at one of these. So when you reached out, it was great. Yeah, Jay Seawall, my background, worked in smart sensors and robotics pretty much my entire career. Navy Labs, I had a startup that I grew and sold, and I worked at a large sensor and robotic manufacturing company. And so, well, smart devices, that used to mean some device that had a processor and actually just did about anything, relatively smart on it. But with Industry 4.0 now, that kind of wraps in robotic interfacing, AI, and IoT, obviously. And coming from a hardware background, software was always a huge part of it. But software monetization and IoT just always seemed to be out of the reach of what we could do as even small or even medium-sized companies. The technology was hard to reach. So we started Numurus to help companies integrate 4.0 connectivity solutions into their products, and started working with Jim at the 5G Open Innovation Labs. On our side, we wanted to integrate 5G into our capabilities, and so that worked out great, and here I am.
Awesome, thank you, Jay. So we're going to hear a lot from Jay in just a little bit, and I'm going to take you guys through a little bit of the 5G journey and maybe bring you up to speed on some 5G aspects that you may or may not know of. But before I do, as Hans mentioned, I'm part of the Washington State IoT Council alongside brethren like Rob Tiffany. The Washington IoT Council was set up initially to bring IoT leaders from across the state to help to build community for IoT and to help build a brain trust here in Washington State with the likes of folks like Rob and others. And so we've put on several events. In fact, February, we had one of our summits that happened pre-COVID. And then we've been hosting a bunch of smaller events virtually that's run by a colleague of ours whose name is Rex St. John, great guy from ARM. So when Hans reached out about the 5G Open Innovation Lab, it's a great tie-in to the great work that's going on today with Washington State IoT Council. On the lab itself, we are trying to build community around the great opportunities that exist in the 5G world, particularly in enterprise. And so we work with companies like Jay's from Numurus that are enterprise focused, looking at building applications and capabilities that run inside 5G networks. And I'll take you guys through a little bit about what 5G is as we see it, a little bit about what the lab's doing to build some of that. And then I'd like to turn the podium over to Jay, have him talk a lot about what Numurus is doing as well. As Hans mentioned, if there's any questions along the way, feel free to pipe in. I'm in presentation mode, so I can't see if anyone's raising their hand. So feel free to interrupt me or Jay if you have any question. We'd be happy to take it.
And Jim, you might want to throw out there, that obviously 5G is a huge, part of the name, but the lab is really around enterprise connectivity solutions, right?
Absolutely, yeah. Actually, we're going to dive a little bit into that in just a moment. So thanks for that shout out. We'll make sure I'll make sure I cover that as we go along. So let's jump into a little bit about what 5G is. As a consumer, you may have heard a lot about its promises of faster connectivity, low latency, better jitter performance, and all that fun stuff. And for the most part, that's absolutely correct. But about 2 years ago, I started thumbing through the 5G specifications published by 3GPP, which is a standards body that writes specifications for the various generations of wireless standards. And what I started to dig in was something a bit more profound. And I think 5G is very different to us all than what 4G or the transition from 3G to 4G is. So let's go through some of the basics. And then again, if you have any questions, please stop me. So the first is what the move to 5G will have significantly higher peak speeds. So today, and this is primarily through carrier aggregation, mostly what we see on our phones is 100 to 200 megs, depending on where you are. In a 5G world, when it's fully built out, there are expectations that we'll get up to 10 gigabytes per second. So your Facebook feed is going to get a boatload faster. But more importantly, new use cases that will have bigger dependencies on bigger wireless pipes will now be made possible. And use cases that include virtual reality, augmented reality, things that use cases that generate a lot of data and need faster pipes for it to execute smoothly. This will be a great benefit for, and we see that happening primarily in the enterprise world. On the latency side, on average today, 4G LTE networks will see anywhere between 40 to 50 milliseconds of latency, which in itself is pretty quick. In a 5G world, taking advantage of millimeter wave, which is the higher frequencies, you're going to see latency performance of sub 10 milliseconds, which is critical, especially for, again, use cases that depend on that type of speed. Autonomous vehicles being a great example of that. On the scale side, the towers that you see around us today, in many cases, can support somewhere between 10,000 to 100,000 concurrent connections. In a 5G world, that starts to go to 1 million concurrent connections per tower or in a square mile. And that's really important. So if the last time you've been to a Sounders game or a Mariners game or a Seahawks game or concert, what have you, you're in the stands, you look at your phone and your phone shows that it's got full bars, but hell, you can't load data or your phone's acting really slow. The reason why is you've got a high concentration of people all trying to hit the similar towers. Our partner T-Mobile has a device called the Cow, which is literally a flatbed 18-wheeler truck that they pull alongside big venues like that to offload some of the traffic from those networks, because those towers and those radios can't support it. In a 5G world, those problems go away, primarily because the capabilities of the RAN, the radio access network, fundamentally so much more significant that you can have a lot more devices connecting to it. And while that's really exciting for our mobile devices, if you look at where IoT is going in a 5G world, and I'm going to lean on Rob to kind of spew some of his insight on this over time in this call, there's almost a 4-time fold of new devices being introduced to networks around the world through IoT, and that's where this figure becomes super compelling and interesting. Now, when you get all of those IoT devices connected to the internet, and GSMA forecasts that by 2025, there'll be over 25 billion new devices on the network. To put that in comparison, in that same time frame, there'll be about 5.9 billion handsets connected to networks. So almost a fourfold increase in the number of connections to wireless networks around the world. Well, those little devices are creating massive amounts of data across the breadth and scale of them. And in today's world with 4G LTE, you're getting about 1/100th of a terabyte worth of data per square kilometer. In a 5G world over the next 5 to 10 years, you're going to probably see that grow to about 10 terabytes. So the network in itself in a 5G world is going to get so much more beefier. But when we look at some of the paths to 5G, there's things that I started to get super excited about and really became the underpinnings of why we launched the 5G Open Innovation Lab. First and foremost, a lot of the networks that we enjoy today are less dense, and in a 5G world, they'll become much more dense. And so I call that network densification, primarily because for some of those speeds and feeds and latency performance in 5G, there's going to be a higher dependency on mid and higher frequencies or millimeter wave. And that means you're going to see a lot more of these little radios that are out and about in city areas and dense urban areas that allow carriers to accomplish those higher speeds. And so networks are getting a hell of a lot more dense as 5G networks start to roll out more and more. And that journey, guys, is going to be a 5 to 10 year plus journey. It's not going to happen overnight. The second is a point that I raised earlier, which is there's going to be a lot more devices connected to the internet, primarily driven, I think, by IoT. And many of those scenarios, in my opinion, will be tied to enterprise. As Jay rightly pointed out, Industry 4.0 is going to have a heavier dependency on data. That data is going to come from new devices that are connected to various parts of a business process that are giving companies real-time insights into either their manufacturing, their distribution, what have you. And so IoT is going to play a much bigger role now, enabled better because of better connectivity. And we'll get into that a little bit. There's a whole new set of new network functions that are going to start to be introduced and rolled out in a 5G world as well, one of which is called network slicing. So think of network slicing as the ability for a carrier to dedicate a slice of their network, a slice of their spectrum to a very specific workload. The example I like to use is Apple, for the sake of its experience for its customers, they may decide that they want a dedicated network slice across all carrier networks. And that network slice is a dedicated slice specifically for Apple users, so they can deliver the best user experience, whether that's in speed, latency, performance, or what have you. Now that a lot of these, the orchestration of these network functions are moving to containerized applications, and because of the specifications in 5G, a carrier now has a lot more control of the radio access network to enable new functions like network slicing. Other functions include dynamic spectrum sharing, carrier aggregation, beamforming, and a few others. That's an example of a new pathway to 5G that gives the carriers a lot more control of their network on the far edge from a radio access perspective. The other big thing that I'm really excited about, and really the genesis behind the 5G Open Innovation Lab, is that much of these new features and performance specs in 5G, while they'll be great for us as consumers, really it's going to have a huge impact in enterprise. ABI Research recently published a paper and presented it about how in the next 15 years, demand for spectrum by enterprises will outweigh demand that currently exists today for consumers. I read another research report that suggests that that carriers will have a bigger dependency on enterprises in various ways. One is in the connectivity through their existing networks, but the second, and this is a growing market opportunity, is that more and more enterprises are looking at deploying their own private cellular networks. And this is obvious in cases where an enterprise like a Chevron, as an example, has remote oil fields or operations where they just want to set up a network to connect devices inside that, and Wi-Fi maybe not the right choice for connecting that. So there is a growing number of, there's a growing number of startups who are building private networking capabilities, and there's growing demand from enterprises to actually build their own private 5G networks. Today, coming out as 4G LTE networks, but in the future, eventually 5G networks as well. So when you look at where 5G is going and you get past a little bit of the marketing hype and start digging deeper into where a lot of the new capabilities are coming and some of these new functions that are going to exist, to me, there's an exciting opportunity in the enterprise world. And for us in the 5G Open Innovation Lab, we wanted to create an ecosystem for enterprise startups to be able to get ahead of that by getting exposed to future 5G networks, thanks to our support from T-Mobile, but also to start to explore what it means to build new 5G apps that could potentially run inside a carrier's network, and app models that are potentially different from what they're used to today. Think of orchestrated apps in big public cloud instances with the ability to orchestrate elements of their applications on the far edge. Now, as I was reading through those specifications from 3GPP, I think it was release 15 at the time, learning more about what's behind or under the hood for 5G, what I had realized was over the 4 generations of wireless standards that have come out, a lot of those networks were essentially fixed purpose networks. So for instance, a T-Mobile would buy great gear from an Ericsson, and a lot of that gear, the core and the RAN, were fixed functions designed for a specific purpose. I'm sorry, my daughter's playing Fortnite, so clearly she won something. But in a 5G world, a lot of those new functions a lot of the underlying technology is being virtualized. And as I mentioned earlier with network slicing, a lot of those new functions on the far edge with the radio are going to depend on orchestration of containerized applications. And so for the most part, guys, carriers are becoming more and more cloud-like in the just the raw execution of their networks over time. And there's a lot of open source projects that are actually taking advantage of where this is going through Linux Foundation. Then there's also an interesting intersection of opportunity as well with the rise in popularity of Kubernetes and serverless computing, and the need for that level of orchestration to happen for functions like network slicing on the far edge. There's a commonality there in Kubernetes interest that carriers could tap into, and that developers and ultimately startups that we're working with are quite interested in exploring. So from my standpoint, 5G is very much a move to the cloud for the carriers. It's a move forward for enterprises to take advantage of what capabilities could exist on the edge for connecting IoT devices and making sense of a lot of that. It's also a great move for startups who are looking to really take advantage of new use cases and explore capabilities that today don't exist, but in future will, thanks to where 5G is going. So moving pretty quickly, there's a few growth opportunities. Some of this is obvious. Some of these things we're working on with startups in our first batch, and as we get closer to announcing our second batch in the next couple of weeks. The first is digital transformation. I mentioned that earlier. Some people refer to it as Industry 4.0. IDC did some research. I believe they were surveying CIOs and CXOs of leading enterprises. And what their research indicated that is that by 2023, I believe, 2023, large enterprises are going to spend about $2.3 trillion on digitally transforming their businesses. And we're seeing that play out even with our partners like Avanade that are having to really fast forward a lot of the digital transformation journeys they had planned alongside some of their enterprise customers. To put that in perspective, $2.3 trillion spent on digital transformation. There's $3.4 trillion spent annually by enterprises on IT services. It was reported by Gartner. This year was forecasted at 3.7, and then due to COVID, it came down at $3.4 trillion. So big amount of dollars being invested by enterprises. A lot of that dependency is going to have a bigger play for IoT. So I think the opportunity for IoT, in my humble opinion, is the horizon of that is actually not too far from us. The second is this private cellular network, something I talked about earlier on the call. Private cellular networks are becoming more and more of a mainstay in enterprises. They're starting to really dip their toe. There is an effort here in the United States that's pretty unique, as you're probably familiar with CBRS. There's been an allocation of spectrum from the CBRS band. I think it's 150 megahertz that the FCC has started to auction off. They did their first round of auctions in July. That auction alone is expected to net the FCC about $40 billion. And a majority of that is expected to go serve the enterprises. So private cellular networks are becoming a real trend. I don't think it's going to be a fad. I do believe that it's going to be part of an IT strategy longer term. Automation is no longer a buzzword. As I mentioned earlier, we have a partner with Avanade that was sharing with our startups back in May, and Jay heard this himself, that they had been working with their enterprise customers on digital transformation journeys that were anywhere between 12 to 18 months out, maybe later for some. And then when COVID hit, in many cases, their customers weren't even able to access their data centers. And so those digital transformation journeys started to come in much sooner, in some cases even 6 months. The reason being is that they weren't able to put people into either factories or people into data centers to actually to execute on their business. And so more of them are now switching to automation with less dependency on human beings for situations like COVID and more dependency on machines. So automation and immersive experiences, the use of augmented reality, mixed reality, virtual reality in enterprises is becoming more mainstream. One of our startups called Tactile has actually an augmented reality experience for the enterprise, and they've got thousands of installs today in the likes of King County and a few other large accounts, including a naval ship, where workers are starting to use augmented reality, capture their frontline knowledge, and share that with other folks. It is not too far of a stretch to suggest that an augmented reality headset could be as important as our PCs are today for doing our jobs. And so those two are big areas where I would say 2 years ago, very much science fiction, couldn't really see a place for this. today, and then certainly in the future, we're starting to see a lot more demand for those technologies emerging. The last is, and this would ring true with this community, if you've got 25 billion devices that are out in the wild that are connecting to networks around the world, your threat vector went from this narrow to this wide, and it's crazy. So just as we're trying to get our hands wrapped around security in the cloud world, in a 5G edge world with 25 billion plus devices expected to be deployed, the risk to security vulnerabilities is so much higher than what we're seeing today. And so from my standpoint, security is a non-negotiable. And in the IoT world, that's going to be a big area that more and more enterprises will likely invest heavily in to ensure that any of the devices that are connected to their networks, that are collecting valuable information, that cannot have any security breaches to, will spend even more money to ensure that those devices are hardened and secured, and all the communications between those devices to an application are equally as hardened and secured. So from my standpoint, security is a big deal in a 5G, post 5G world, and certainly as more devices come online. The last is really the unknown use cases, and I have a phrase here that only time will tell on who will become the next Uber and who will become the next Sears. Really, the use capabilities that we're expecting to be made possible in 5G, the new market opportunities that are really rooted in enterprise, are going to open up the doors for folks like Jay and their startups to really explore in those capabilities and to solve some real problems. Those that can see those problems and solve them early, theoretically the next Ubers. Those that hold on to what the past is and aren't willing to really look around the corner and see what's possible in the future could become the next Sears. So this is an opportunity for us all to think differently. And this is something that I've been pushing alongside our partners. It's probably of no surprise to you all that when Steve Jobs walked on stage back in 2007 when the first iPhone and essentially lit up the largest app ecosystem push that we've all experienced, even at my time at Microsoft, there was a big transformation of creating value, for the most part, transitioning over carriers' networks, right? Trillions of dollars of new business opportunities, new capabilities that were created by the likes of an Uber, an Airbnb, or Marketo, or what have you, that essentially traversed over a carrier's network. And that was well and good, but for a carrier like a T-Mobile or a Verizon or British Telecom, Rogers, whomever it is, it's very expensive to build out these networks. In the U.S. alone, the three national carriers of T-Mobile, Verizon, and AT&T collectively carry over $120 billion worth of debt on their balance sheets. And that compares to, I think it's $60 billion worth of debt that Amazon, Microsoft, and Google carry on their balance sheets. So building these networks are super expensive. Seeing a lot of that value transition over your network, not a bad thing for the app builders, obviously, but for a carrier, it wasn't something they benefited from, and they're essentially an interesting and very compelling part of the problem, part of the solution rather. What we're trying to explore here in the lab is to work alongside companies like Jay's and others that are now building some new capabilities that could run directly inside a carrier's network. And it's a bold ambition that we have, but it's one that we've been pushing forward with, that ultimately opens up the far reaches of edge networks by way of just the raw real estate that carriers have and these new capabilities that are coming online with 5G, as I explained earlier, with a commonality, and I've just indicated Kubernetes as an example of that, but the commonality being that there's a built-in developer ecosystem already that's pursuing serverless computing and containerized applications with orchestration like Kubernetes or Docker Swarm. From my time at Microsoft, the big lessons that I'd learned in my 13 and a half years there is that platforms are enablers for value creation. Apps build the values, those apps pull through the platform. And that's what we're exploring and building out in capabilities for the 5G Open Innovation Lab. So we're focused on building that ecosystem of enterprise startups that are looking to take advantage of new 5G capabilities, working closer with where the edge networkings exist today and where those capabilities will eventually come online over time, and then working with a host of partners that include T-Mobile and Intel and Avanade and NASA, and then we have 3 other new founding partners that we're hoping to make announcements on in the next little while. So I'll stop there because I covered a lot of ground and I want to make sure there are any questions I can answer. Oh.
So it looks like we have a few questions.
Okay.
Yeah. And you can take them now?
Sure. Happy to.
Yep. Chang, do you want to ask your question? Is he still there? Oh. No. All right. So I'll just read out the question. So he's asking, how will backhaul keep up with 5G? Could you please explain the backhaul capacity between number of connections, lots of sensors, versus total throughput required?
Yeah, that's a great question. I'm going to make a blanket statement. Rob, you can call BS on this if I'm wrong, but most of the carrier networks today are outfitted with fiber. So a lot of the base stations you see in place today, they're backhauled to central offices and ultimately to the evolved packet cores run by carriers is all fiber based. And there's more than enough capacity in those networks from what I've read. I could be wrong, but there's more than enough capacity there. Where we've been limited is on the front haul, right? The ability for these radios to have the number of connections that will undoubtedly change in a 5G era to be able to connect, and then of course the throughput performance as well.
Cool. So I can ask one more, and
sure.
Then Carl, can we wait to the end for yours? You'd be okay with that? I can give Jason a shot. So my question was the private networks. Who's deploying and managing these? Is it the enterprise or the telco? Does the telco look at this as an opportunity? What's the kind of business model there?
That's a great question. So there's actually a number of startups that are building private enterprise network platforms. One of which we've worked with called Expedo, based out of Canada. Michael Anderson, their CEO, is based out of Portland. So Expedo is one. A partner of the lab called Solona is another one. They raised publicly 10 million. I think they've raised more privately. Solona is another one that's pursuing it. We're chatting with a company called FreedomFi, also based out of Silicon Valley, that's building private enterprise networks today for GLTE, but in future 5G as well, and they're basing that capability on CBRS. I have seen, and this is very spotty, so I'm not an expert in this, but I have seen that some carriers are actually looking at building an offering of their own, leveraging their licensed spectrum as well. But that market is still very, very new, and it hasn't really built its momentum yet. But the demand for private cellular networks is real. I'll give you an example. One of our startups that we're bringing on board is in the distribution shipping world. I'm not going to name names because we want to hold back. And they, one of their customers is the largest port here in the United States. And that port has hundreds of acres of land for its operations, of only which 1/3 of that area is covered with cellular connectivity, and it's in probably the second or third largest city in the United States. So kind of do the math. So that is a great example of a large instance that has poor coverage, where private cellular connectivity is absolutely necessary for the operations of which they perform, and frankly, even for the security of our country, given the operations of running ports. But that's an example where there's people walking around with clipboards and paper that are doing their jobs versus using the great potential of IoT, private cellular connectivity, processing of that as an edge, connecting obviously to a big cloud service. And that's just one of several examples that exist where a need for private cellular networking is really important today.
Awesome.
Yep.
It looks so. Carl had a comment around this as well. He's saying Microsoft will jump into 4G,
absolutely
5G private network.
Yes.
Yeah. Carl?
That's exactly what they're going to do.
Yeah.
You can see it very clearly with Azure, their Azure cloud services. But that's not my question. Can I ask my question?
Sure.
Yeah, go ahead.
All right. So I'm working for a stealth embedded software security for IoT and blockchain company, and I'd like to know how you and I, or my company and you, can essentially interface. I've sent an email on LinkedIn. You didn't respond. I went to your website multiple times and left my contact details. I'm really just trying to chat with you. And the question is actually, how do you integrate IoT devices with blockchain for trusted identity? Because Microsoft is all about, Yeah, Microsoft is into DID, right? And also data privacy protection.
Carl, did
So
we met at a Create 33 event back in?
we did.
Yes.
We did when I
I
was
apologize. Yeah.
No worries. No
Yeah.
worries. You were at the SIG Alliance, Bluetooth SIG Alliance, I think.
No, you were there, and then you came over to join our event when we did a panel with Intel and others. You had just popped in. I remember,
cool,
and I
cool.
apologize for not following up earlier.
Right.
I will look up.
No worries.
I will look up for your ping online, or just send me a note at jim@5goilab.com, and I'm happy to follow up with you on that. There's a bunch of work that's happening today, and some of which I can talk to you about when we connect.
Okay.
But it's an area that a lot of vendors are doubling down on. Intel certainly, Microsoft certainly, AWS certainly. So there's a lot of things that are happening, and I could, based on your specific requests, I think I can help you route to the right people. It's an area that I have some passion on, but I'm not the security expert. I do have some colleagues that are, that I'd be happy to put you in touch with.
Yeah. Yes. What I wanted to do is just have an introduction about what my company does, because I'm the ex-Gemalto, Trustonic, and ARM guy, so I know security. Let's talk privately, please.
Please, and I'm sorry for not responding. If you had sent notes, I apologize for that.
No worries. You're a busy guy. You're building bridges, and I just want to jump on the bridge.
Okay.
All right.
Come on board. We have some space. All right. Well, with that, I'm going to turn it over to Jay. I'm sorry I took more of your time too. I apologize. I'd love to give you.
That's fine.
Give me a
how about I share my screen for now, and then I'll switch back.
Go for it. I'll go ahead and stop on my side. There you go.
All right. Let me know when you can. So just to kind of introduce, as I mentioned, Jim asked me to provide some overview on IoT from our standpoint, and a little bit of information on what we do as a company. This is a high-level, overview for industrial IoT. Specifically, most of the work we do is working with companies that are developing smart sensors or smart devices that have some type of onboard AI that could actually essentially be, updated on a daily basis for different operations, or continuously moved around, for different projects. And how do you manage that? And most of the time, I'm talking to people that, again, hardware developers, or embedded software developers, that IoT is not their, they're not don't have deep knowledge on. So I kind of apologize. There's probably people here that know much more about IoT than I do. But what I really wanted to show with this is to kind of just touch on some of the major areas that come into the development when you're putting together an IoT solution, and really highlight maybe some of the challenges. As a hardware-focused company, the amount of knowledge and capabilities need to be brought to the table to create a solution. Obviously, if all you need to do is send a temperature up to the cloud and display it, there's lots of solutions to do that these days. But to build an infrastructure that you can monetize IoT around your hardware, and integrate AI, manage it, and other cloud services, it becomes an entire solution that, again, smaller, medium-sized companies, hardware companies, have a difficult time not only developing but maintaining. So looking at the communication support, so typically there's two types of connections that our customers and their products are trying to connect through: high bandwidth communications and low bandwidth. And a lot of these systems, again, they're moving around. They're either on a mobile robotic platform or some type of mobile platform, or they're just being moved to different parts of an industrial facility. And so on the high bandwidth, obviously you've got your Ethernet, your Wi-Fi, 4G, 5G. There's some high bandwidth RF. And on the low bandwidth, IR, RF, satellite type communications. The satellite one is kind of one of my favorite low bandwidth ones to talk about. We did a project last year, essentially connecting up 1,000 smart ocean floats. and those ocean floats had 10, 15 sensors on each one of them, and the customer wanted to be able to circle a geographical region and turn on and off a bunch of different onboard classifiers or processing every day, and get that information back through satellite connections. And those under that program for a while, we were the biggest users of the Iridium satellite communications in the North America area. And they limited us to 340 bytes of data every 4 hours. So out of those 10, 15 sensors, we had to process that down and pass 340 bytes of status, GPS tracks, and essentially, the information the client was interested in. And so, working around 340 bytes of information and trying to pack that up, encrypted and get it out there was quite a challenge, but it really hit home the difference between, what you can do on a high bandwidth and a low bandwidth link. So one of the points on this is, getting into the IoT space, there's one thing to set something up on the device and in the cloud, but you also, the actual communications gateways you're working around are another technology you need to bring into the fold. With those high bandwidth, you can do a lot. You can move all your raw data, the software updates, manage digital twins. With the low bandwidth, you're looking more at status messages, snippets of information, sending configurations back and forth. And again, it's not an either or. A lot of our customers and the products we work with are moving in and out of these high bandwidth and low bandwidth, and so they want continuous ability to get status updates and to change configurations even when they have these very low bandwidth connections. But when they do have high bandwidth, they want data to be automatically uploaded, software updates to be deployed and tracked, and keep digital twins of their devices. So message packing, this really goes back to the, when you have these low bandwidth connections, we would create on those floats, we would create about 2 gigabytes of data an hour. I should say 2 gigabytes, 2 gigabytes of data. We would process that down to about 50 megabytes of data of information an hour. And then we had to, when we had that satellite link, we had to essentially pick the top 340 bytes of information to send up. And so, prioritization in that situation is a key capability. Building an encryption on both sides of the messaging, then packing that up, and then managing. A lot of times these messages are packed into the limits to some message size per message, and so you have to then layer on a multi-packet management system. Software deployment. So one of the really nice things with containers these days, you can create a solution that in the cloud is completely independent of what cloud environment you're running on. And again, a lot of our customers, some of these deployments they don't have a high-speed connection to the cloud, and so what they'll even do is set it up on a server somewhere, and again deploy that container on just a field server. Same thing on the devices. The ability to deploy containerized solutions that again are not dependent on the operating system capabilities integrated into it can really speed up the development and deployment. And then looking at security, this is a huge one. Probably one that keeps myself and many other people in this industry up at night is how much is enough, because you can spend pretty much all your development dollars on security, but you don't. You want to make sure that you're meeting not only your customers' expectations, but obviously, as a product, you don't want that to be compromised. So root of trust. This is really each component from hardware to the firmware, to the software apps that are running on the device, to the cloud. At each connection point, there's some trust made and assumed between the component that's moving the data and the component that it's receiving it. And so most of these other ones can be handled in software. Root of trust, from the initial boot, how do you know that the firmware that's booting is trustworthy? And so that's when you can start to even get into actual hardware components that come into this process. These other ones are, for anybody that works on defense programs, this is kind of the minimal capabilities of even unclassified systems these days that are used in the defense groups. But they're also just as important, and they come up. The same list comes up when you're talking to industrial customers that are working on assets that, if compromised, could be quite expensive or catastrophic. And so you've got encryption at rest, in transit, password management, two-factor authentication, all the way down to breach monitoring. And so the breach monitoring is interesting because obviously you want to allow access, but you want to be able to track, if someone's trying to access it, that's not supposed to. And so there's, you can do that through just, restricting access completely to a very small number of IP addresses. But then, you can get into limiting situations there. So the other way to do it is really monitoring and looking for, strange characteristics to the messaging, like multiple data coming from the same device, when you know that it should only be talking every hour and things like that. So, oh yeah, and then so once you have it all connected, you want to do something useful with that connection, and so software. This is particularly on the cloud side, the software management. So that's managing the actual software that's running on the device. As I mentioned, a lot of our clients, these are devices that are running some type of AI that need to be updated fairly regularly with either for applications or just improved AI solutions. The portal creation, this is really where the website development was 10, 15 years ago, where it started out where you did everything in-house, and then some companies came out with tools you could build websites faster, and now you've got resources like WordPress, right? And so in a matter of days, you can have an amazing website. And so that's really where this the portal customization is going. And then cloud services, connecting up third-party cloud services, whether it's data mining or statistics, AI training. But again, these are some of the components that in a solution you'd want to bring to the table. And then looking at, how do you get to that solution? So obviously, Amazon and Microsoft and Google putting quite a bit of money into developing and creating tools and solutions around IoT. And so, if you're an IoT company and you've got an IoT team, then they can really accelerate that. But if you're, again, a smaller, mid-sized hardware company, that means that you're still going to have to put together a team in-house if you want to build something off of those. In the middle there, you've got companies that really focus on industrial IoT, mostly service-based, professional service-based companies, and looking to support fairly large organizations and bigger contracts. What you're starting to see come to market for the industrial IoT space now is companies like my own Numurus with our NEPI product, and Zipit and IoT Connect, where they're developing low-cost subscription solutions that allow these smaller, medium-sized companies to essentially develop and deploy their solutions quite rapidly at an affordable price. So with that, just a few slides on what we're actually Numurus is doing. As I mentioned, our company is focused on helping other companies integrate 4.0 capabilities into their products. So our NEPI suite covers robotic interfacing, the AI management, so frameworks on the edge, as well as AI training solutions in the cloud, and the IoT connectivity connection. Really, this is trying to help companies make that transformation that you saw with the flip phones, the smartphones 10, 15 years ago. But again, these companies don't have the budgets that Apple and others had to do that, and so a great opportunity for support and helping these companies get there. So we've been actually doing this for a number of years now, and what we're in the process of doing is developing a subscription-based IoT solution that really wraps up and abstracts a number of the kind of development and technological parts of that IoT solution. And so the solution integrates data management, so not only moving that data through the low bandwidth and high bandwidth connections, but organizing it for the end customer. User portal creation. So I mentioned the WordPress. So we're developing a WordPress type development platform. Again, allow our customers to tailor the solution to their particular products. The cloud services, we got a number of different companies on the robotic and sensing and analytics side that have cloud services that we can layer in this as additional subscription capabilities. And then device management. So as we have AI training solutions in the cloud, essentially populating a library of edge AI solutions, you want to be able to quickly provision those to the device and keep track of digital twin, if anyone's familiar with that term, of tracking what the hardware configurations are in your device in the field. And again, if you've got a temperature sensor that has just a small bit of software that's rarely ever changing, that's not a big deal. But if it's a robot or some smart camera that the software is changing regularly, quite important to know what that configuration is. And so one of the things we're doing with that subscription model is setting up an engagement structure with the customer that essentially put some of our software on their device. They set up an enterprise account, which essentially creates a white labeled interface for their products. They can then tailor that customer experience, as I mentioned, the different portals, the different cloud services, maybe AI training type solutions they want to integrate into it, and then market that to their customers. Their customers buy their products. They can go to that landing page, create their own accounts, and in the background, we're hosting all of that, as well as managing all the billing, and provide essentially a new profit center for the customer. So not only are they making their products, I guess, more valuable to the end customer, they now have this new revenue and profit center. So for anybody that's ever worked in a hardware company, the holy grail is always not giving your software away, but how can I monetize that software investment? Because there's still quite a bit of software work in a hardware company, and so this is where we're going. And if anyone out there is interested in working on a hardware company or developing some type of device and interested in learning more, I'd love to talk about it.
Okay. Thank you, Jay. Hans, do we want to go straight to some questions, just to be cognizant of people's time?
Yeah, or we have 5 minutes. Did you have more slides you're going to go over?
Nope. That's it.
Nope. Okay. Yeah. So we'll just start going through the questions here. I think we asked, Carl got to ask his. So Eric, do you want to ask your question? I think you had two. No, one.
I just had one. I was just curious, what percentage of the U.S. landmass do you figure will be covered by 5G in the next few years?
That's a great question. There's been some public statements from the various carriers. T-Mobile's been very public about their low-band 600 megahertz spectrum that they have that should cover, I don't know what the number is, greater than 80% of U.S. areas. But in some cases, like even just a few miles outside of Pasco, Washington, you start to really see some drop-off. So I don't know what the exact number is. T-Mobile's approach was really to deploy a nationwide 600 megahertz network and then layer on mid and higher band spectrums for some more of that 5G performance. My hope, though, is that as more and more enterprises start to deploy their private 5G networks or today 4G LTE networks, that will have an offshoot of coverage in areas where they are remote, and those networks could potentially be access points for other folks to use. That's my hope.
All right, thank you.
You're welcome.
All right. I don't know if I'm going to be able to pronounce the name. Xin Cheng? I apologize if I butchered it.
Sure. I just want to ask, like, your point of view on the 5G versus other technology like LoRa, Sigfox. Like, what's their sweet spots and respective use cases? How do you think about it?
Yeah, Rob, I don't want to put you on the spot. I'm going to try my best on this from what I've seen and learned, but I'd love for you to keep me honest on a lot of this. Release 16 of 3GPP specifications have come out, and what I've seen is a lot more blending of 5G, Wi-Fi 6, LoRa, and some of these other protocols where there's just going to be a lot more access, and then it depends on whoever's operating the networks in terms of how they want to support those various protocols. That's what I've read, but Rob, maybe you have a better opinion on that than I do.
Yeah, I mean, just at a high level, the comparison between Sigfox and LoRaWAN would be, either Cat-M1 LTE-M, which is an IP-based, low-power, long-range network, or NB-IoT, narrowband IoT, which is probably even more a closer approximation of what you're doing with LoRa. Which is not IP-based and it's more fixed. It doesn't have mobility. It doesn't roam around. It's less data. But those two capabilities, they actually are part of the last stuff. Actually, with 4G and LTE, but it's moved forward and we're enhancing it in the later 3GPP specs and 5G. So those are kind of like your cellular equivalents of Sigfox and LoRa.
All right. Stuart?
Hi, yeah, my question is similar to Xin Cheng's. Jim, it's good to see you again.
Likewise, Stuart.
My question was kind of more narrowing in on specifically IoT devices and like low power ones on batteries. The areas where like Sigfox and LoRaWAN and stuff like that, they talk about having devices that work for years on a battery out in the field. Like, how does 5G work with that sort of low power IoT device?
It's a great question.
Just going to be NB-IoT again. That's kind of carrying forward with 5G, and actually a newer rev, as Jim kind of alluded to a little bit. The power consumption is going to get even more efficient than it is today. It's already really good, but it probably isn't as good as LoRa. But it's certainly heading in that right direction.
I just to add to that, and this is a bit of a stretch, but I do think what we'll see with the iPhone 12 launch is a pretty significant tipping point in the components world, where you'll start to see a lot more 5G modems being deployed, not just in mobile phones, but that's going to open the aperture for more 5G into devices, IoT devices and such. And Apple's just that tipping point, that it's that force in the market that's going to make that difference.
Yeah. Carl, you had a question for Jay.
Hey, Carl. I can't hear you, Carl. So
it's always fun to say you're on mute,
but he's not.
Yeah, that's weird. Carl? Yeah, we can't hear you anymore. All right. No. All right. You
Can you type in his question?
Yeah, maybe. He asked a question. He typed earlier, Jay. It was about, do you see AI being embedded more into cloud servers or IoT cellular modules? We see AI being embedded into modules to be closer to the edge.
Yes. Yep.
Yeah, no, I think more and more it's the cloud you leverage to train the AI, and then and then using the communications and the just the amount of processing available on the edge to run these now is just incredible, and just keeps getting better. And so a lot of it too comes back to while the bandwidth is there, sometimes to move a lot of data, a lot of times it's not, and customers don't want a lot of data. In the end, they really want to become they want to trust the AI solution, and they just want to get the answer. And when you start looking like the oil industry, they when they have detect maybe a pressure, some characteristic in a pressure monitoring system, they want it to run multiple secondary AI type characterization solutions that try to analyze that rapidly rather than moving that data back. So yeah.
And Carl says exactly.
And go kick the tires on that tiny ML stuff too, if you want.
Yes. Yeah. Good. I've actually been working on putting together just a tiny ML session just to look at who's here, who's working on it locally.
We're just to interject here for a second, Hans. We're working with a startup that's coming into our next batch that's embedding AI capabilities inside FPGAs.
Okay.
It's not IoT, right? But think about a dumb IoT device that collects the data and can be run and processed on FPGAs at a nearby cloud server on the edge. That I'm also seeing that as well, Carl. And I don't think they're the first to doing it. There's others who are in that space as well.
Yeah, you have to make an introduction for me, Jim.
You betcha I will. Betcha I will.
All right, Chang.
Can you guys hear me now?
Yes. Yeah. Yes.
Okay. Hey, I think Jason already answered the question about who's going to be doing device management. So it looks like Numurus will offer it. So I'll ask a question on top of that is, out of the protocols that are out there, I recently worked with Lightweight M2M and MQTT. Do you see any protocol kind of leading or being more efficient or adopted for industrial IoT?
I would say, every customer has their own opinion. It seems it's really the challenge. It's not. I mean, you walk into a meeting and very quickly you're being told. It's really what they have experience with. So I don't have an answer now. But I actually, what I would say is that I'm quite interested to see with some of these new satellite constellations, I guess the offer and vision of having high-speed connectivity anywhere in the world at low cost, really could change things. It's not 5G connectivity, but it's more than the 340 bytes that we have to work with the satellites right now.
Yeah, I wonder if that might act as the backhaul, and then you have to have a gateway for the whether you connect via Bluetooth or Wi-Fi, whatever else the local.
Yeah, and again, it could be multimodal systems that when they are hitting 5G, they're dumping all their data or and uploading software, and then they're hitting these satellites as they move out of 5G and using those just for status and information sharing and things like that. It's typically, it's rarely one communication is going to solve every situation or need.
Yeah, thanks.
Yeah.
I think that was the last question on the chat. So I have one for Jim. So that kind of related to what Carl was talking about. So how do folks get in touch with you? What's the criteria? How do you select? It sounds like September, you already have your next batch. How do folks get in touch with you?
You just got to buy them a really nice espresso machine.
Jay knows me. And Rob knows this too. I'm a coffee geek, but no, you can't buy me off that way. But we just went through a selection of 15 companies, hopefully 16 if we can land this next one next week. Really, what we're looking for, guys, are enterprise startups They're really going to drive this revolution that I was talking about earlier. And so Dave's a great example of it. Expedo, Tactile, others are great examples of the kinds of companies that I think will really be attractive to our partners. Again, that includes T-Mobile, Intel, Avanade, NASA, and then we have 3 others we're hoping to announce shortly. We're stage agnostic, and we don't take any equity. So this is not an acceleration program. We're really wanting to work with a bunch of startups in the enterprise world that are going to create this ecosystem for 5G, and ultimately, hopefully, give the carriers an ecosystem to plug into that makes use of their networks in a bigger way. So we've had companies that are earlier stage, and we've had companies. In fact, we're bringing a company in that's about ready to raise its Series B for this next round. So a lot of information is available on our current website at 5goilab.com. I've dropped my email address if you want to reach out. I will respond. I'm sorry for missing the other gentleman's follow-up, but we'd love to chat. And our next batch will start off in April of next year. So we're already starting to recruit. There was a number of great companies that we are looking to bringing on for April of next year.
Cool. And it's worth mentioning too. One of the things that I really enjoyed was hitting all the investment groups around here. Seattle is quite a focus on certain software aspects. As soon as you start talking about, hardware is a 4-letter word around here, and so through Jim and the 5G Lab, you really got connected, with bringing together investors that are really interested in this space, the industrial space, which was great because it's you're not going to find that many around here.
Yeah, that's right. We had InQtel, we had Dell Ventures, Samsung, T Ventures, which is T-Mobile's venture arm, was at the table. We had a few different folks, and we're drawing on venture firms guys from both coasts and then in the middle of the country as well. So we have a diverse set of investors that we've been able to tap into. Our next investor event, which our alumni will also be invited to participate, like Jay as well, will happen just after Thanksgiving is our current time frame. So we're growing that. We're growing that investor interest. And what investors like about the program is that we are stage agnostic. So we have a bunch of different companies at different stages that speak to different theses, but they also are highly inquisitive to where 5G and edge is going. And they see this program as being fairly unique, and they like the quality of deal flow they're seeing from it. So if we can help you, even though you're not part of the program, to get some access to some of those investors where we can broker those introductions, we're happy to facilitate. Ultimately, this is about building community, so it's not exclusionary from that standpoint.
Awesome. Any other questions? Otherwise, I think we're good. We're finished on just a little bit over, but that's cool. All right.
Hans, thanks for hosting us. We really appreciate it on behalf of the lab and the Washington State IoT Council. We appreciate you guys joining in and listening today. And Jay, thanks for stepping in to present.
Yeah, thank you.
It's quite an honor. Yeah, I appreciate it. And Rob, thank you for joining to listen in. Appreciate it. All right, guys.
Awesome.
Thank you all. Have the rest of your day.
Yes, you too.
Take care. Thank you, guys.
Bye.
Bye-bye.
Thank you.